Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to business mathematics and statistics. This is lecture number 1st, chapter number 14, statistical description of data. Now, let's start with statistic. Introduction of statistics. The modern development in the field of not only management, commerce, economics, social sciences, maths, and so on, but also in our life like public services, defense, banking, insurance sector, tourism and hospitality, police and military, etc., are dependent on a particular subject known as statistics. Statistics does play a vital role in enriching a specific domain by collecting data in that field, analyzing the data by applying various statistical techniques, and finally making statistical inferences about the domain. In the present world, statistics has almost a universal application. It becomes universal applications. Our government applies statistics to make the economic planning in an effective and pragmatic way. The businessmen plan and expand their horizons of business on the basis of the analysis of the feedback data. The political parties try to impress the general public by presenting the statistic of their performances and accomplishment. Most of the research scholars of today also apply statistics to present their research papers in an authoritative manner. Thus, the list of people using statistics goes on and on and on. Due to these factors, it is necessary to study the subject of statistics in an objective manner. Statistics used in every field. Like public services, defense, banking, management, commerce, economics, social science, mathematics, in business, in political way. Okay. So economics becomes, statistic becomes the necessary subject to studying. Now, history of statistics. Going through the history of ancient period and also that of medieval period, we do find the mention of statistics in many countries. However, there remains a question mark about the origin of the word statistics. One view is that statistic is originated from the Latin word status. According to another school of thought, it had its origin in the Italian word statista. Some scholars believe that the German word statistic was later changed to statistics, and another suggestion is that the French word statistique was made as statistics with the passage of time. This is the history of statistics. Definition of statistics. Now, what is statistics? We may define statistics either in singular sense or in a plural sense. Statistics, when used as a plural noun, may be defined as data qualitative as well as quantitative that are collected usually with a view of having statistical analysis. However, statistics when used as a singular noun may be defined as a scientific method that is employed for collecting, analyzing and presenting data. leading finally to drawing statistical inferences about some important characteristics. It means it is science of counting or science of averages. Science of counting and science of averages. Application of statistics. Among various application of statistics, let us confine our discussions to the field of economics, business management and commerce and industry. Economics. Modern development in economics have the roots in statistics. In fact, economics and statistics are closely associated. Economics and statistics are associated with each other. Time series analysis, index number, demand analysis, etc. are some overlapping areas of economics and statistics. In this connection, we may also mention econometrics, a branch of economics and economics that interacts with these statistics in a very positive way. Branch of economics that interact with these statistics in a very positive way. Conducting socio-economic surveys and analyzing the data derived from it are made with the help of different statistical methods. Regression analysis, one of the numerous applications of statistics, plays a key role in economics for making the future projection of demand of goods, sales, prices, quantities, etc., which are all ingredients of economic planning. Business management. Gone are the days when the managers used to make decisions on the basis of hunches, intuition, or trials and errors. Nowadays, because of the never-ending complexity in the business and industry environment, most of the decision-making process rely upon different quantitative techniques, which could be described as a combination of statistical methods and operations research techniques. So far as statistics is concerned, inferences about the universe from the knowledge of a part of it known as sample plays an important role in development of certain criteria. Statistical decision theory is another component of statistics that focuses on the analysis of complicated business strategies with a list of alternatives, their merit as well as demerits. They describe the merits as well as demerits. Okay. Statistics in commerce and industry. In the age of cutthroat competition, like the modern managers, the industrialists and the businessmen are expanding their horizons of industries and businesses with the help of statistical procedures. Data on previous sales, raw materials, wages and salaries, product of identical nature of other factories, etc., are collected, analyzed, and experts are consulted in order to maximize profits. On the base of these, how we increase the profit. How we increase the profits on the basis of collected data. Okay. Measure of central tendency and dispersion, correlation and regression analysis, time series analysis, index numbers, sampling, statistical quality control are some of the statistical methods employed in commerce and industry. Limitations of statistics. There are some limitations of statistics. Before applying statistical methods, we must be aware of the following limitations. Then first one is statistics deal with the aggregates. An individual to a statistician has no significance except the fact that it is a part of the aggregate. Second one is statistics is concerned with quantitative data. However, the qualitative data also can be converted to quantitative data by providing a numerical description to the corresponding qualitative data. Third one, future projection of sales, production, price and quantity etc. are possible under a specific set of conditions. If any of these conditions is violated, projections are likely to be inaccurate. Fourth limitation is the theory of statistical inferences is built upon random sampling. The theory of statistics is depend on the random sampling. If the rules for random sampling are not strictly adhered to, the conclusion drawn on the basis of these unrepresentative samples would be erroneous. In other words, the expert should be consulted before deciding the sampling scheme. Now, next topic is collection of data. We may define data as quantitative information about some particular characteristics under consideration. Although a distinction can be made between a qualitative characteristics and a quantitative characteristics, but so far as the statistical analysis of the characteristics is concerned, we need to convert qualitative information to quantitative information by providing a numeric description to the given characteristics. In this connection, we may note that a quantitative characteristic is known as a variable, or in other words, a variable is a measurable quantity. The quantitative characteristic is known as a variable, or in other words, a variable is measurable quantity. Again, a variable may be either discrete or continuous. There are two types of variable, discrete or continuous. When a variable assumes a finite or a countably infinite number of isolated values, it is known as a discrete variable. When a variable assumes a finite or a countably infinite number of isolated values, it is known as a discrete variable. Example of discrete variables may be found in the number of petals in a flower, the number of misprints a book contains, the number of road accidents in a particular locality, and so on. A variable, on the other hand, is known to be continuous if it can assume any value from a given interval. Known to be continuous if it can be assumed any value from a given interval. Example of continuous variable may be provided by height, weight, sale, profit and so on. Finally, a qualitative characteristic is known as an attribute. The gender of a baby, the nationality of a person, the color of a flower, etc. are example of attributes. We can broadly classify data as primary and secondary. There are two types of data, primary and secondary. Collection of data plays the very important role for any statistical analysis. The data which are collected for the first time by an investigator or agency are known as primary data, whereas the data are known to be secondary if the data is being already collected are used by a different person or agency. Primary data are collected by an investigator or an agency for the first time, that known as the primary data. If the data already collected or used by a different person or agency, that's called the secondary data. If Professor Das collects the data on the height of every student in his class, then this would be primary data for him, because he collects the data of height of every student for the first time. Okay. If however another person say Professor Bhargava uses the data as collected by Professor Das for finding the average height of the students belonging to that class, then the data would be secondary for Professor Bhargava, because that is already taken by the Professor Das. Okay. So that data called the secondary data. If any data being already collected or used by another person, then that's called the secondary data. Professor Das, he collected the data for the first time of the student of students, height of the students in his class. Okay. So first time it means primary data, and Professor Bhargava uses the collected data by Professor Das of his class. So that's called the secondary data. Okay. Collection of primary data. The following methods are employed for collection of primary data: interview method, mailed questionnaire method, observation method. Questionnaire is filled and sent by enumerators. Interview method again could be divided into personal interview, indirect interview and telephone interview method. Interview method divided into three parts: personal interview, indirect interview. Third one is telephonic interview or telephone interview method. In personal interview method, the investigator meets the respondent directly and collects the required information then and there from them. In case of a natural calamity like a super cyclone or an earthquake or an epidemic like plague, we may collect the necessary data much more quickly and accurately by applying this method. If there are some practical problems in reaching the respondent directly, as in case of a rail accident, then we may take resource for conducting indirect interview, where the investigator collect the necessary information from the persons associated with the problems. Telephone interview method is quick and rather non-expensive way to collect the primary data, where the relevant information can be gathered by the researcher himself by contacting the interview over the phone. The first two methods, though more accurate, are inapplicable for covering large areas, whereas the telephone interview, though less consistent, has a wide coverage. The amount of non-responses is maximum for this third method of data collections. Mailed questionnaire method comprises of framing a well-drafted and soundly sequenced questionnaire covering all the important aspects of the problem under consideration and sending them to respondents with prepared stamp after providing all the necessary guidelines for filling up the questionnaire. Although a wide area can be covered using the mail questionnaire method, the amount of non-responses is likely to be maximum in this method. In observation method, data are collected. Data are collected. As in case of obtaining the data on the height and weight of a group of students by direct observation or using instrument. Although this is likely to be the best method for data collection, it is time consuming, laborious and covers only a small area. Questionnaire form of data collection is used for larger inquiries from the persons who are surveyed. Enumerators collect information directly by interviewing the person having information. Questions are explained and hence data is collected. Sources of secondary data. There are many sources of getting secondary data. Some important sources are listed below. International sources like WHO, ILO, IMF, World Bank, etc. B. Government sources like Statistical Abstract by CSO, Indian Agriculture Statistic by the Ministry of Food and Agriculture and so on. C. Private and quasi-government sources like ISI, ICAR, NCERT, etc. D. Unpublished sources of various research institutes, researchers, etc. Next, scrutiny of data. Since the statistical analyses are made only on the basis of data, statistical analysis made only on the basis of data. It is necessary to check whether the data under consideration are accurate or not, or as well as consistent. No hard and fast rules can be recommended for the scrutiny of data. One must apply his intelligence, patience and experience while scrutinizing the given information. Errors in data may creep in while writing or copying the answer on the part of the enumerator. A keen observer can easily detect that type of error. Again, there may be two or more series of figures which are in some way or other related to each other. If the data for all the series are provided, they may be checked for internal consistency. As an example, if the data for population, area and density for some places are given, then we may verify whether they are internally consistent by examining whether the relation density is equal to area by population holds. A good statistician can also detect whether the returns submitted by some enumerators are exactly of the same type, thereby implying the lack of seriousness on the part of the enumerators. The bias of the enumerator also may be reflected by the return submitted by him. This type of error can be rectified by asking the enumerators to collect the data for the disputed cases once again. This type of error can be minimized or rectified by asking the enumerator to collect the data for the cases once again or second time. Okay. Presentations of data. Once the data are collected and verified for their homogeneity and consistency, we need to present them in a neat and condensed, condensed form, highlighting the essential features of the data. Any statistical analysis is dependent on a proper presentation of the data under consideration. Classification or organization of data. It may be defined as the process of arranging data on the basis of the characteristics under consideration into number of groups or classes according to the similarities of those of the observations. Following are the objectives of classification of data. A. It puts the data in a neat, precise and condensed form so that it is easily understood and interpreted. B. It makes comparison possible between various characteristics if necessary and thereby finding the association or the lack of it between them. C. Statistical analysis is possible only for the classified data. D. It eliminates unnecessary details and makes data more readily understandable. Data may be classified as chronological or temporal or time series data. Second one, geographical or spatial series data. Qualitative or ordinal data. Quantitative or cardinal data. When the data are classified in respect of successive time points or intervals, they are known as time series data. The data are classified with respect to time or successive time points are known as time series data. The number of students appeared for CA final for the last 20 years, the production of a factory per month from 2000 to 2015, etc. are example of time series data. Like how many students appeared for CA final exam for the last 20 years. Okay. Like for the in 2000, how many students appeared for the CA final exam? In 2001, how many number of students appeared for CA final? Like that. Okay. So, data are classified with respect to the time points or intervals. Okay. So, that is known as time series data. Data arranged region wise are known as geographical data. Geographical data name suggests that the data arranged region wise. If we arrange the students appeared for CA final in the year 2015 in accordance with different states, then we come across the geographical data. Because we collected the data or arranged the students for CA final into year 2015 in accordance with the different state. State is a region, so that data called the geographical data. Data classified in respect of an attribute are referred to as qualitative data. Data on nationality, gender, smoking habit of a group of individuals are example of qualitative data. Lastly, when the data are classified in respect of a variable, say height, weight, profits, salaries, etc., they are known as quantitative data. The data that is variable, that called the quantitative data, like height, weight, profit, salary, etc. Data may be further classified as frequency data and non-frequency data. The qualitative as well as quantitative data belong to the frequency group, whereas time series data and geographical data belong to the non-frequency group. Frequency group, qualitative as well as quantitative data belong to the frequency group, or time series data and geographical data belong to non-frequency group. Mode of presentation of data. Next, we consider the following mode of presentation of data: textual presentation, tabular presentation or tabulation. Third one is diagrammatic presentation, representation. Textual presentation. This method comprises presenting data with the help of a paragraph or a number of paragraphs. The official report of an inquiry commission is usually made by textual presentation. Following is an example of textual presentation. In 2009, out of a total of 5,000 workers, of Roy Enamel Factory, 4,200 were members of a trade union. The number of female workers was 20% of the total workers, out of which 30% were members of the trade union. Trade union were members of a trade union. In 2010, the number of workers belonging to the trade union was increased by 20% as compared to 2009, of which 4,200 were male. The number of workers not belonging to trade union was 950, of which 450 were females. The merit of this mode of presentation lies in its simplicity, and even a layman can present data by this method. The observation with exact magnitude can be presented with the help of textual presentation. Furthermore, this type of presentation can be taken as the first step toward the other method of presentation. Textual presentations, however, is not preferred by a statistician simply because it is dull, monotonous, and comparison between different observations is not possible in this method. For manifold classification, this method cannot be recommended. Tabular presentation or tabulation. Tabulation may be defined as systematic presentation of data with the help of statistical table having a number of rows and columns and complete with reference number, title, description of rows as well as columns and footnotes if any. We may consider the following guideline for tabulation. First, a statistical table should be allotted a series number along with a self-explanatory title. Second, the table under consideration should be divided into caption, box head, stub and body. Caption is the upper part of the table. describing the columns and subcolumns, if any. The box head is the entire upper part of the table, which includes columns and subcolumns numbers. Units of measurement along with captions. Stub is the left part of the table, providing the description of the rows. The body is the main part of the table that contains the numerical figures. Third, the table should be well balanced in length and breadth. Fourth, the data must be arranged in a table in such a way that the comparisons between different figures are made possible without much labor and time. Also, the row totals, column totals, the unit of measurement must be shown. Fifth, the data should be arranged intelligently in a well-balanced sequence, and the presentation of data in the table should be appealing to the eyes as far as practicable. Sixth, note describing the source of the data and bringing clarity and, if necessary, about any rows or columns known as footnotes should be shown at the bottom part of the table. The textual presentation of data relating to the workers of raw enamel factory is shown in the following table. Status of the worker of raw enamel factory on the basis of their trade union membership for 2009 and 2010. Status here: member of TU, trade union. TU means trade union. Non-member and total. Male, female. Total, male, female. Non-member, total, male, female, total. So here in 2009, 3900, female 3000. So T, it becomes 4200. Non-member 300, female 500, total 800. 4200, female 800, total 5000. In 2010, 4200 plus 840 is equal to 5040. Non-member male 500 plus 450, 950. Total 4700 plus 1290 is equal to 5990. Source: footnote, TU, trade union. M, F and T stand for trade union, male, female and total respectively. The tabulation method is usually preferred to textual representation as it facilitates comparison between row and columns. Complicated data can also be represented using tabulation. Third, it is a must for diagrammatic representation. Fourth one, without tabulation, statistical analysis of data is not possible. C. Diagrammatic representation of data. Another alternative and attractive representation of statistical data is provided by charts, diagrams and pictures. Unlike the first two methods of representation of data, diagrammatic representation can be used for both the educated section and uneducated section of the society. Furthermore, any hidden trend present in the given data can be noticed only in its mode of representation. However, compared to tabulation, this is less accurate. So, if there is a priority for accuracy, we have to recommended tabulation. We are going to consider the following type of diagrams. First, line diagram or bar diagram, and third one is pie diagram, pie chart. Line diagram or line diagram or histogram. Here also line diagram or histogram. When the data vary over time, we take recourse to line diagram. In a simple line diagram, we plot each pair of values t, yt. Yt representing the time series at the time point t in the ty plane. The plotted points are then joined successively by line segments, and the resulting chart is known as line diagram. When the time series exhibits a wide range of fluctuations, we may think of logarithmic or ratio chart, where log y and not y is plotted against t. We use multiple line chart for representing two or more related time series data expressed in the same unit and multiple axis chart in somewhat similar situations if the variables are exposed in different variable are expressed in different units. Second is bar diagram. There are two types of bar diagrams, namely horizontal bar diagram and vertical bar diagram. While the horizontal bar diagram is used for qualitative data or data varying over space, the vertical bar diagram is associated with the quantitative data or time series data. Bars, rectangles of equal width and usually of varying lengths, are drawn either horizontally or vertically. We consider multiple or group bar diagrams to compare related series. Component or subdivided bar diagrams are applied for representing data divided into a number of components. Finally, we use divided bar charts or percentage bar diagrams for the comparing different components of a variable and also the relating of the components to the whole. For this situation, we may also use pie chart or pie diagram or a circle diagram. Illustrations. Example: the profits in lakhs or rupees or lakhs of rupees of an industrial house for 2009, 2010, 2011, 12, 13, 14, 15 are 5, 8, 9, 6, 12, 15 and 25, 24 respectively. Represent this data using a substitutable diagram. We can represent the profits for 7 consecutive years by drawing either a line chart or a vertical bar chart. Figure shows the line chart and figure 14.2 shows the corresponding vertical bar charts. Like in 2009, there is a 5. In 2010, 8. 2010, 8. And so on. Showing line chart for the profit of an industrial house during 2002 to 2008. Showing the vertical bar diagram for the profit of an industrial house from 2007 to 2015. Example 14.2. The production of wheat and rice of a region are given below. Year 2012 to 2015. Wheat 12, 15, 18, 19. Production in metric tons. Rice 25, 30, 32, 36. Represent this information using a suitable diagram. Solution. We can represent this information by drawing a multiple line chart. Alternatively, a multiple bar diagram may be considered. These are depicted in figure 14.3 and 14.4 respectively. Product ton in metric terms on y-axis, year on x-axis. So, here in 2012, production in metric ton, wheat 12 ton, rice 25. Wheat 12 ton and rice is 25. 2013, 15 and 13, 30. 15 and 30. Multiple line chart showing the production of wheat and rice of a region during 2012 to 2015. Dotted line represent production of rice and continuous line represent that of wheat. 2012, 13, 14 and 15. Rice and wheat. This is for rice and this is for wheat. Multiple bar chart representing production of rice and wheat from 2012 to 2015. Okay. All information represented by the bar chart. Now, example 14.3. Draw an appropriate diagram with a view to represent the following data. Source, revenue in millions of rupees, customs 80, excise 190, income tax 160, corporate tax 75, miscellaneous 35. Solution. Pie chart or divided bar chart would be an ideal diagram to represent this data. We consider pie chart. Source, revenue in million rupees. Source, customs, excise, income tax, corporate tax, miscellaneous. Revenue in million rupees 80, 190, 160, 75, 35. Here central angle for the pie chart is equal to 2 by total of 2 into 360. 80 by 540 into 360 is equal to 53 degree. 190 by 540 into 360 is equal to 127 degree. 160 upon 540 into 360 is equal to 107 degree. 75 by 540 into 360 is equal to 50. Miscellaneous 35 is revenue in miscellaneous rupees is 30. in million rupees, 35 million. So 35 upon 4, 540 into 360 is equal to 23 degree. So total of these 53 plus 127 plus 107 plus 50 plus 23 is 360, and total revenue in million rupees is 540. Using the pie chart, X size, arrow sign, IT, dotted line, custom, CT, pie chart showing the distribution of revenue. Now next topic is frequency distribution. As discussed in the previous section, frequency data occur when we classify statistical data in respect of either a variable or an attribute. A frequency distribution may be defined as a tabular representation of statistical data, usually in an ascending order, relation to a measurable characteristic according to individual value or a group of values of the characteristics under study. In case the characteristic under consideration is an attribute, say nationality, then the tabulation is made by allotting numerical figures to the different classes. The attribute may belong, like in the illustration, counting the number of Indian, British, French, German, and so on. The quantitative characteristics is divided into a number of categories or classes which are mutually exclusive and exhaustive, and the figures against all these classes are recorded. The figure corresponding to a particular class signifying the number of times or how frequently a particular class occurs is known as the frequency of that class. Thus, the number of Indians is found from the given data signifies the frequency of the Indians. So frequency distribution is a statistical table that distributes the total frequency to a number of classes. When tabulation is done in respect of a discrete random variable, it is known as a discrete or ungrouped or simple frequency distribution. And in case the characteristics under consideration is a continuous variable, such as classification is termed as grouped frequency distribution. In case of a grouped frequency distribution, tabulation is done not against a single value In case of group frequency distribution, tabulation is done not against a single value as in the case of an attribute or a discrete random variable, but against a group of values. The distribution of the number of car accidents in Delhi during 12 months of the year 2005 is an example of an ungrouped frequency distribution, and the distribution of heights of the students of St. Xavier's College for the year 2004 is an example of a grouped frequency distribution. Example 14.4. Following are the records of babies born in a nursing home in Bangalore during a week. Construct a frequency distribution according to gender. Solution. In order to construct a frequency distribution of babies in accordance with their gender, we count the number of male births and that of female births and present this information in the following table. Frequency distribution babies according to gender. Boy and girl, number of births 16 and number of girl 14. 16 plus 40 is 30. Frequency distribution of a variable. For the construction of a frequency distribution of a variable, we need to go through the following steps. First, find the largest and smallest observation and obtain the difference between them, known as range, in case of a continuous variable. Second, form a number of classes depending on the number of isolated values assumed by a discrete variable. In case of a continuous variable, find the number of class intervals using the relation number of class intervals x interval into class length is range is equal to range. Third, present the class or class interval in table known as frequency distribution table. Apply tally mark a stroke against the occurrences of a particular value in a class or class interval. Count the tally marks and present these members in the next column, known as frequency column, and finally check whether the total of all these class frequencies tally with the total number of the observations. Example 14.5. A review of the first 30 pages of a statistic book reveals the following printing mistakes. Now, make a frequency distribution of printing mistakes. Solution. Since x, the printing mistakes, is a discrete variable, x can assume 7 values 0, 1, 2, 3, 4, 5 and 6. Thus, we have 7 classes, each class comprising a single value. Frequency distribution of the number of printing mistakes of the first 30 pages of a book. Printing mistakes 0 to 6. Tally marks 0 how many times? 1, 2, 3, 4, 5. 0 5 times. Tally marks 0 5 times. 1 5 times. 2 1 2 3 4 5 and 6. 2 6 times, same as 3 6 times. 4 4 times. 5 2 times. 6 2 times. Frequency number of pages 5 5 6 6 4 2 2, total 30. Example 14.6. Following the weight in kgs of 36 BBA students of St. Xavier's College. Construct a frequency distribution of weights taking class length as 5. We average maximum weight minus minimum weight 73. Maximum weight and minimum weight. So 73 minus 44. You can find out maximum weight and minimum weight from the question. There are 73 is big in this line. 73 bigger than 73? No. So 73 is maximum weight minus minimum weight is Minimum weight is 44. So 73 minus 44. 29 kgs. Number of class interval into class length range. Number of class interval into 5 range 29. So number of class interval is equal to 29 by 5, approximately 5 6 are 30, approximate 6. We always take the next integer as the number of class interval so as to include both the minimum and maximum value. Frequency distribution of weights of 36 BBA students, 44 to 48 telemarks 3, number of students 3, 49 to 53 4, 4, 54 to 58 5, 59 to 63 7, 64 to 68 9, 69 to 73 8. Total number of students or frequency is 36. Some important terms associated with a frequency distribution. Class limit CL. Corresponding to a class interval, the class limit may be defined as the minimum value and the maximum value the class interval may contain. The minimum value is known as the lower class limit and the maximum value is known as the upper class limit. For the frequency distribution of weights of BBA students, the LCL and UCL lower class limit and upper class limit of the first class interval are 44 kgs and 48 kgs respectively. Class boundary CB. Class boundary may be defined as the actual class limit of a class interval. For overlapping classification or mutually exclusive classification that exclude the upper class limits like 10 to 20, 20 to 30, 30 to 40, etc. The class boundaries coincide with the class limits. This is usually done for a continuous variable. However, for non-overlapping or mutually inclusive classification that includes both the class limits like 0 to 9, 10 to 19, 20 to 29, which is usually applicable for the discrete variable we have. LCB, lower class boundary, is equal to lower class limit minus d by 2. UCB is equal to UCL plus d by 2. D is the difference between the lower class limit of the next class interval and the UCL of the given class interval. For the data presented in table 10. LCB of the first class interval 44 kgs minus 49 minus 48 divided by 2, that is the difference D, capital D. 49 minus 48 is difference by 2. So 44 minus 49 minus 41 by 2, 0.5. 44 minus 0.5 is 43.50 kg. And the corresponding UCB 48 kg plus in UCB plus in LCB minus plus 49 minus 48 by 2 kgs. So it becomes 48.50 kg. Midpoint or mid value or class mark corresponding to a class interval. This may be defined as the total of the two class limits or class boundaries to be divided by 2. Thus we have midpoint is equal to LCL plus UCL divided by 2. LCB plus UCB divided by 2. Using this we can find out the midpoint or mid value or class mark. Referring to the distribution of weight of BBA students, the midpoints for the first two class intervals are 44 kg plus 48 by 2 and 49 plus 53 by 2. So 44 plus 48 is 92. 92 by 2 is equal to 46. 49 plus 53, 102 by 2, it is 51 kg. Width or size of a class interval. The width of a class interval may be defined as the difference between the UCB and the LCB of the class of that class interval. For the distribution of weight of BBA students, see the class length or width is 48.50 kg minus 43.50 kg is equal to 5 kg. For the first class interval, for the other class intervals also C remains same, 5 remains same. Cumulative frequency. The cumulative frequency corresponding to a value for a discrete variable and corresponding to a class boundary for a continuous variable may be defined as the number of observations less than the value or less than or equal to the class boundary. This definition refers to the less than cumulative frequency. We can define more than cumulative frequency in a similar manner. Both types of cumulative frequency are shown in the following table. Cumulative frequency distribution of weights of 36 BBA students. Weights in kg 43.50, 48.50, 53.50, 58.50, 63.50, 68.50, 73.50. Cumulative frequency less than and more than. Less than start with 0, 33 plus 3 or 36, 0 plus 3 or 3, 3 plus 4 or 7, 7 plus 5, 12, 12 plus 7, 19, 19 plus 9, 28, 28 plus 8, 36. More than 33 plus 3, 36, 29 plus 4, 33, 24 plus 5, 29, 17 plus 7, 24, 8 plus 9, 17, 0 plus 8, 8 and 0. Frequency density of a class interval. It may be defined as the ratio of the frequency of that class interval to the corresponding class length. The frequency densities for the first two class intervals of the frequency distribution of weights of BBA students are 3 by 5 and 4 by 5, 0.60, 3 by 5 is 0.60 and 4 by 5 is 0.80 respectively. Relative frequency and percentage frequency of a class interval. Relative frequency of a class interval may be defined as the ratio of the class frequency to the total frequency. Class frequency to the total frequency. Percentage frequency of a class interval may be defined as the ratio of class frequency to the total frequency expressed as a percentage. For the last example, the relative frequencies for the first two class intervals are 3 by 36 and 4 by 36 respectively, and the percentage frequencies are 300 by 36 and 400 by 36 respectively. It is quite obvious that whereas the relative frequencies add up to unity, the percentage frequencies add to up to 100. Graphical representation of a frequency distribution. We consider the following types of graphical representation of frequency distribution. Histogram or area diagram, frequency polygon, ogives or cumulative frequency graphs. Histogram or area diagram. This is a very convenient way to represent a frequency distribution. Histogram help us to get an idea of the frequency curve of the variable under study. Some statistical measure can be obtained using a histogram. A comparison among the frequencies for different class interval is possible in this mode of diagrammatic representation. In order to draw a histogram, the class limits are first converted to corresponding class boundaries and a series of adjacent rectangles, one against each class interval, with the class interval as base or breadth, and the frequency or frequency density usually when the class intervals are not uniform as length or altitude is erected. The histogram for the distribution of weight of 36 BBA students is shown below. The mode of the weights has also been determined using the histogram. Mode 66.550 kgs. Showing histogram for the distribution of weight of 36 BBA students. Number of 8 y-axis number of students or frequency. Weight in kgs. Mode 66.50 between 63.50 and 73.50. Frequency polygon. Usually frequency polygon is meant for single frequency distribution. However, we also applied it for group frequency distribution provided the width of the class intervals remains the same. Frequency curve can be regarded as a limiting form of frequency polygon. In order to draw a frequency polygon, we plot xi fi for I is equal to 1 to n, with xi denoting the midpoint of its class interval and fi the corresponding frequency, n being the number of class intervals. The plotted points are joined successively by the line segments and the figure so drawn is given the shape of a polygon, a closed figure, by joining the two extreme ends of the drawn figure to two additional points x00 and xn plus 1 0. The frequency polygon for the distribution of weights of BBA students is shown in figure. We can also obtain a frequency polygon starting with a histogram by adding the midpoints of the upper side of the rectangle successively and then completing the figure by joining the two ends as before. Let's see in diagram or figure. Midpoint 46, 51, 56, 61, 66, 71. Number of students 3, 4, 5, 7, 9 and 8 with respect to midpoints. Here showing frequency polygon for the distribution of height 36 BBA students. At 46 number of students is 3. At 46 point number of students is 3. At 56, 51, 4. At 51 point there is a 4 students and so on. Ogives or cumulative frequency graph. By plotting cumulative frequency against the represent class boundary, we get ogives. As such, there are two ogives. Less than type ogives obtained by taking less than cumulative frequency on the vertical axis, and more than type ogives by plotting more than type cumulative frequency on the vertical axis, and thereafter joining the plotted points successively by line segments. Ogives may be considered for obtaining quartiles graphically. If a perpendicular is drawn from the point of intersections of the two ogives on the horizontal axis, then the x value of this point gives us the value of median. The second or middle quartile ogives further can be put into use for making short-term projections. Figure depicts the ogives and the determination of the quartiles. This figure gives us the following information. First quartile or lower quartile Q1 is equal to 55 kg. Second Q2 or ME 62.50 kg. Third Q3 68 kg. So here showing the ogives for the distribution of weights of 36 BBA students. On y-axis cumulative frequency and on x-axis weights. Here we get the point Q1 55 kg. Q2 at 62.50. This is not 63, this is 53. Q2, that is Q1 and Q3. Okay. We find Q1, Q2, Q3 frequency curve. A frequency curve is a smooth curve for which the total area is taken to be unity. A frequency curve is a smooth curve for which the total area is taken to be unity. It is a limiting form of histogram or a frequency polygon. The frequency curve for a distribution can be obtained by drawing a smooth and freehand curve through the midpoints of the upper side of the rectangles forming the histogram. There exist four types of frequency curves. First, bell-shaped curve, U-shaped curve, J-shaped curve, mixed curve. Most of the commonly used distributions provide bell-shaped curve, which as suggested by the name looks almost like bell. The distribution of height, weight, mark, profit, etc. usually belong to this category. On a bell-shaped curve, the frequency starting from a rather low value gradually reaches the maximum value somewhere near the central part and then gradually decreases to reach its lowest value at the other extremity. For a U-shaped curve, the frequency is minimum near the central part and the frequency slowly but steadily reaches its maximum at the two extremities. The distribution of Kolkata bound commuters belongs to this type of curve as there are maximum number of commuters during the peak hours in the morning and in the evening. The J-shaped curve starts with a minimum frequency and then gradually reaches its maximum frequency at the other extremity. The distribution of commuters coming to Kolkata from the early morning hour to peak morning hour follows such a distribution. Sometimes we may also come across an inverted J-shaped frequency curve. Lastly, we may have a combination of these frequency curves known as mixed curve. These are exhibited in the following figures. First, bell-shaped curve. Frequency density versus class boundary. The shape becomes like bell. U-shaped curve. Here in U shape the frequency is minimum near the central part. Minimum near the central part. J-shaped curve. In J-shaped curve, start with a minimum and gradually reaches its maximum. Start with a minimum and gradually reaches its maximum. Mixed curve. This is the mixed curve. So, this lecture is over here. In the next lecture, we will first summarize the whole lecture and then start with the exercise questions. Okay. So, bye.